Hi, this is Mrs. Kidman, and I am so excited to be talking to you about one of my favorite topics, rational numbers versus irrational numbers. So let's start by taking a look at some different types of numbers. First numbers we're going to look at are called natural numbers. Now, when we're discussing the set of natural numbers, we often use this notation here, which is that fancy n. And the set of natural numbers just includes numbers like 1, 2, 3, etc. So all of those positive integers, that's considered a natural number. Now, the next set of numbers we're going to talk about are the whole numbers. And the whole numbers include the natural numbers, but it also includes the number 0. So when we're talking about those whole numbers, sometimes we use this scripted W to describe it, but it's 0, 1, 2, 3, etc. So all of those positive integers and 0. Now we keep using the word integer. So what is an integer? Well, an integer is just all of the positive and negative whole numbers. So when we talk about the set of integers, we usually use this fancy scripted Z, but the set of integers is just positive and negative whole numbers. So we're looking at numbers like -3, -2, -1, 0, 1, 2, 3, etc., all the way on. Those are the integers. Okay, and the whole numbers and natural numbers are a subset of those integers. The next type of numbers that we're going to look at are called rational numbers. Now, rational numbers is a really big key in this lesson when we compare rational versus irrational numbers. So what makes a number rational? Well, a rational number, rational sound includes the word ratio, and a ratio is just a proportion. And so in this case, a rational number is a number where we have an integer over another integer. Notice it looks just like a fraction. And that's kind of the key thing about a rational number. If I can write a number as a fraction, then it's rational. If I can't write it as a fraction, it's not rational. But it's going to be an integer over an integer, or a positive or negative number over another positive or negative number. Now, as opposed to a rational number, we do have numbers called irrational numbers, and they're kind of a subset of the real numbers, but they don't include anything in the rational numbers. So they're the opposite. Now those irrational numbers cannot be written as a fraction, and they're numbers that kind of go on forever. So think of numbers like pi, e, the square root of 2, stuff like that, where they're not really a quote unquote pretty number, but they are beautiful in their own sense. They're just not quite as simple. So those are irrational numbers. The real numbers include both the irrational numbers and the rational numbers. So it's that set of both types of numbers. There are another type of numbers called imaginary numbers, and those include something called I, which equals the square root of -1, but we're not going to discuss that in this video. So let's go ahead and work on classifying types of numbers as either rational or irrational. So the square root of 5. If I take out my calculator and I did the square root of 5, what I would end up getting is something like 2.236067, blah, 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 blah. That's not a nice number. So this is going to be irrational. A quick tip with square roots is if our square root does not equal a whole number or an integer, then it's considered irrational. So let's look at -3. Well, -3, I could write that as a fraction of -3/1. So that one is rational. 5/8, that's already written as a fraction, so I know it's going to be rational. Square root of 16, if I do that in my calculator, I'm going to get 4. Now 4 is an integer, so I know that this is rational here. The cubed root of 27. The cubed root is kind of like the square root. In a square root, you need 2 of them. In a cubed root, we need 3. So the cubed root of 27 actually equals 3 itself. So that one is rational. The square root of 18, well, that one comes out to be something like 4.24 something, something, something. So that is not an integer, so it is irrational. This -0.25 or -25 hundredths, well, we could write that as -25 hundredths, which simplifies to -1/4. And that's a fraction, so we know that that's rational. 8.7, that one's also going to be rational because that's 8 7/10. So 8 7/10, and we just wrote that as fraction, so we know it's rational. Pi, lastly, is irrational. It's a beautiful number, but it goes on forever without repeating, so that makes it irrational. So that's kind of how we would classify rational or irrational. The biggest thing that I want to ask myself is, can I write it as a fraction? And if I can, then it's rational. And if I can't, then it's irrational. So let's take a look at another way we can identify whether or not a number is rational or irrational, which is by looking at its decimal. If its decimal can be written as a fraction, then we know that it works. Now, these types of decimals that we're talking about are called repeating decimals and terminating decimals. And there are two different kinds here. So a terminating decimal gives us a fraction. Okay, so this terminating decimal is something like if I did 1 divided by 4, or 1/4, that's going to be 0.25. Notice how that ends there. So that is a terminating fraction. Another type of terminating fraction is a whole number. So say I had like the number 3. Well, 3 can be written as a decimal as 3.0. Notice how it terminates or it stops. It doesn't go on forever. Therefore, those are terminating. And notice those terminating fractions can easily be written, or terminating decimals can easily be written as a fraction. Similarly, if I had a decimal and I didn't have the fraction version of it, so 7.251, this right here, remember by place value is tenths, hundredths, thousandths, 10,000ths. So I could easily write this as a fraction as being 7,251 10,000ths, right? That's a huge fraction, but it's a fraction nonetheless. Therefore, we can write it as a fraction. If we can write it as a fraction, therefore it's rational. Now a repeating fraction, that's something else that we want to look at. A repeating fraction is something like 1/3. If I divide 1 by 3, I'm going to get 0.333333 repeating, right? We know that. If I do 1 divided by 9, I'm going to get 0.1111 repeating. That's what happens. So a repeating fraction is one where it repeats that set of numbers over and over and over again. One that I want to look at is 1/99. Now 1/99 equals 0.01010101, where that 0.1 is repeated. Notice how we have this set of numbers, that 0.1 chunk. It's repeated. It's like we copied 0.1 and then paste over and over. That's what it means when it says repeat. It's like we copy and pasted a set of numbers over and over. That's very different than this decimal here, 0.0100100001, right? This one has a cool pattern, but it is not repeating. Because remember, repeating means it has to be a copy paste. And here we increase the number of zeros. So even though there's a pattern, this is actually an irrational number because it isn't repeating, it just has a pattern. However, the one up above it is rational because it's repeating. So that's a quick way that we can check whether or not something is a repeating decimal or if it's a terminating decimal. Both of those mean that it's going to be rational. If it doesn't repeat or terminate, if it's neither, then it's going to be an irrational number. And that's what we see with those square roots. Now, the last thing we want to cover is if we see something like these proper fractions, we want to switch them to an improper fraction because that tells us that it matches the definition of a rational number where it's an integer divided by an integer. So let's take a look at one of these, 5 2/7. To change it from a proper fraction to an improper fraction, sometimes we use this method called around the world, where we know that here I have 5 whole pieces of 7. 1, 2, 3, right? So I have 5 whole pieces here of 7. 6, 7, right? And then I have 2 more little pieces here. So I can count that 7 plus 7, or I have 5 of those. So this right here, I've got it 5 times. And then I have 2 more. So I can count that 7, 14, 21, 28, 35, 36, 37. So I have 37 sevens. Now notice how we had 5 of those. So I could just do 5 times those 7 pieces right here, and that gives me 35 plus our 2 additional pieces. Sometimes we use that around the world method of the denominator times the whole number plus the numerator, and that'll give us the number on top. Now, that works great, but when we're looking at this fraction over here where we have a negative whole number, where it's negative 2 3/5, this is all negative. So I have negative 2 here divided into 5. Here's negative 2 wholes divided into 5 pieces, and then 3 more little negative pieces. So I'm going to put little negative signs in all of these. So total, how many negatives do I have? 5, 10, 13 negatives. So I have a negative 13 divided into groups of 5. So that's really what this equals. So this one, we can't do that around the world method. We can, but we have to ignore this negative and add it at the end. So 2 times 5 plus 3 is 13, and then added my negative to give me a negative 13/5. So as a quick summary of this, a rational number is a number that we can write as a fraction. And that fraction has to be an integer, which is a positive or negative whole number, over another integer. And those rational numbers, if we look at them as decimals, they either terminate, which means they end, or they repeat, which is that copy paste. So if we find a number that either can be written as a fraction or as a decimal that terminates or repeats, then we know it's going to be a rational number. And that is how we decide if a number is rational or irrational.